Today we're going to focus on factoring polynomials and finding zeros. So one thing you need to remember, or that you need to understand about polynomials, is that they can be written as a product of linear factors. For example, if I had the polynomial f of x equals x squared minus 7x plus 6, this can be factored into two binomials, x minus 1 times x minus 6. Now, these are two factors. Both are what we call linear factors because the x inside is to the first power. Something else I would like for you to notice is that the degree of the polynomial, in this case, this polynomial has a degree 2, has the same number of factors as the degree. So one of our rules that we're going to try to follow, and we're going to remember when we are factoring polynomials, is that the number of factors equals the degree. So a polynomial of degree n, because n can stand for any number of degree, has the same number of factors. So if we have a third degree polynomial, we will be writing the product of 3 factors, fourth degree, 4 factors, and so on. So today we are going to be talking about factoring polynomials, but this is just the very beginning of our factoring. And so today what we're going to focus on is if we are given a factor, so given a factor, we want to completely factor. And when we say completely factor, we mean we need to find the other remaining factors. So given a factor, I want to completely factor the polynomial. And we're going to do this using synthetic division. So we use synthetic division because it's a shortcut of long division. And so once we use the factor we're given, we're going to find the remaining factors using synthetic division, and then we're going to find the zeros. And this is exactly what you have to do on your homework. So your homework should be modeled just like your notes today. So let's look at a few examples of how you're going to be factoring today. So those are the directions of today's notes, and those are the same directions for today's assignment. So we're going to call this polynomial p of x. And we can call it whatever we want. So this one's called p. And this is equal to 2x squared plus 5x minus 3. And what I want to do is I want to be given information that x plus 3 is already one of my factors. So what that means is that when I'm trying to completely factor my polynomial is going to be x plus 3 times another polynomial that I need to find. And so because this is a second degree polynomial, I'm only going to have 2 factors. They gave me one of them, and I have to do some synthetic division to find the other. So that's the first part. The other piece is now remembering, how am I going to use synthetic division? So with synthetic division, one of the pieces that we looked at was I need to look and see when is x plus 3 equal to 0. And that's going to happen when x equals negative 3. When setting up your synthetic division, again, remember your polynomial must be in descending order, and you must have all of the powers listed. And in this case, I do. So I'm going to put my negative 3 on the outside, and I'm going to use my coefficients on this quadratic. And because this is a factor, because they're giving us one of the factors, we must get a remainder of 0. So at least I will be able to have a method to check to see if I'm at least going in the right direction. So negative 3 times 2 is negative 6. Now remember, with synthetic division, we add vertically. So 5 minus 6 is a negative 1. Negative 3 times negative 1 is a positive 3. And when I add vertically, I get a 0. And this was my remainder. And again, because this is a factor, this must happen. So when I have a second degree polynomial here, and I divide by a first degree polynomial, what's left are the coefficients on the 1 power less. So again, if this was a second, this came from a first, I have to have 1 power less in my denominator here, or in my bottom row. And so my other factor now is 2x minus 1. So this is what my polynomial looks like completely factored. All right, given the one factor, I use synthetic division to find the other. Now when I'm asked to find my zeros, I already have one of my zeros. I used the first factor to get one of my zeros. So now the other factor, when I set that one equal to 0, if I add 1 and divide by 2, I get that x equals 1/2. And so these two are my zeros. These are the places that will, or the values that will make this polynomial equal to 0. Again, we want to be able to use this information later down the road to help us graph. And so right now we're just going to start with this first step. All right, so this is our first beginning part that we want to work with. But this is that's your work, that's your strategy every time. So let's look at a few more. So I'm going to call this one f of x. And so it has a different name. That's okay. 6x squared plus 14x plus 4. And I'm given that x plus 2 is a factor. Now one thing that I want you to recognize is that when you are factoring, you always have to make sure you factor out a GCF first. So when I'm writing down my f of x, I'm going to have to take out a factor of 2 first. If I don't take out a factor of 2, then I'm not going to have a more simplified polynomial. And so what that means is when I go to look at the polynomial that's remaining, this is the polynomial I want to work with when I am using the x plus 2 in synthetic division. So right now, I still have the factor of 2, but I also have a factor of x plus 2 that comes from this 3x squared plus 7x plus 2. And I do need to still find my other factor. So they're giving me an x plus 2 factor. I have to take out the GCF also. Now, when you use your synthetic division, you're going to want to use this polynomial right here. You're not going to use this original anymore because I've taken out the GCF and I'm looking at a simpler function. So again, when I'm looking at part of my zeros, and I'm trying to figure out what am I going to use on the outside of synthetic division, that's going to be part of my work as well. So I'm going to use negative 2 on the outside here. But now I'm going to use these coefficients from my more simplified polynomial. And again, that's in descending order, not missing any pieces. And so let's bring the 3 down. And we should still get a 0 if we do this right as a remainder. Negative 2 times 3 is negative 6. Add straight down. Negative 2 times 1 is a negative 2. And add straight down. And again, you can see we got no remainder. The 3 is the coefficient on the square. And so since this is a quadratic divided by a linear, then again 1 power less gives me the variable and the constant. And so my other factor is 3x plus 1. And so this is the completely factored form of my original polynomial. And the last thing I have to do is find my other 0. So I'm going to set this other factor equal to 0. Now when I subtract 1 and divide by 3, I'm going to get my other 0 as negative 1/3. Now a lot of times students will get confused with what do I do with the 2 on the outside? Well, if you set that factor equal to 0 and solve, there's nothing to solve. There's never a time when 2 can be equal to 0. I have no variable. And so what happens is that's not possible. So it's not one of my zeros. So again, start seeing what we're doing here. We have 2 zeros. Right? We have 2 binomial or linear factors. We have a second degree polynomial.